These triangles look like what we've been doing this whole week, okay? The only thing is the placement of the numbers is going to be in the same place every single time. These lines are parallel. So you can only use this method. So this is kind of like a cheat method. If you use the small over big triangle equals small over big triangle and you cross multiply like we've been doing all week, this will also work for that. The only problem with using small triangle kind of problems is sometimes you will end up with a quadratic. A quadratic is like the quadratic formula from algebra 1. It's like factoring quadratics and solving for x. So we are not going to use small triangle over big triangle concept. We're going to kind of cheat the system if we know it's parallel. So see these little double arrows? So that arrow means it's parallel. This arrow means it's parallel. So if you have these little double arrows, you can cheat the system, okay? If you don't have the arrows, you can't cheat the system, okay? If you wanted to do small over big, you could, but then you'd have quadratics, and we don't want to do that because quadratic formula is a whole situation. Okay. So if you know DE is parallel to AC, because they either tell me that or they have these cute little arrows on my picture, then what I could do, I'm going to put variables on my picture. So we're going to basically write an equation. If I call this W and I call this X and I call this Y and I call this Z, okay, I'm just saying that they're like some numbers that exist in the world. What we could do is we could take W and we can divide by, instead of doing W plus Y, because that would represent the whole length of this side, instead of adding them, we're just going to do W over Y. Because we know they're parallel, this will work for these kind of problems. On the other side, we have small triangle, which is X, and we're dividing by, instead of X plus Z representing the whole length, we're just putting it over Z. The converse, when we rearrange sentences, converse just means working backwards. So we're flipping the sentence. If I know that W over Y is equal to X over Z, then I could say that the two lines are parallel. So converse just means like using common sense. Well, if I can work this way, then I can use that same thought process to just work backwards. Converse is just flipping your sentence. So let's set up number 1. So we're going to start by just picking something on the small triangle. 12. So remember, you have a small triangle here. And then remember, you have the big triangle, which represents the whole thing. Okay. So we have 12. And on that same line, we're not going to do 12 plus 14. We're going to cheat the system. We're going to say 12 over 14 because 14 is on that same side. Equals, what else is on the small triangle? 15 over X. And then we're going to cross multiply and divide. So today's is very nice. You'll realize that these are you're gonna fly through these. So if you do 14 times 15, you get 210. X times 12 is just 12x. So if I divide, what do I get? What? Divide? 17.5. Is that what you said? I think you like subtracted or something. I don't know. Yeah.
Why would the big one be 17.6?
So you could do that. You'd get the same exact answer. The problem is whenever you have like if we went to the back, so if you did a problem like, don't write this, okay? But if you did number 5, okay, I'm going to do number 5 the way I do not want you to do these problems. So do not write this on the back. So if we did X plus 7 is on the small triangle over the entire length, if I add these together, it would be X plus 10 equals, right? Does that make sense? I combine my terms. Okay. Small triangles, 2x plus 4 over 2x plus 8. You could do this mathematically. You could multiply binomials times binomials, which depending on how your Algebra 1 teacher taught you, whenever I teach it, I use a box. So x plus 7 multiplied by 2x plus 8. I don't know if you guys use box. Some of you might have just used FOIL, but 2x times x would give you 2x squared. And then x times 8 gives you 8x. And then 2x times 7 is 14x. And then 7 times 8, what is that? 7 times 8, why am I having a brain fart? things. And then you combine like terms. Anyways, it's going to make quadratics. And then you're going to have a quadratic that equals a quadratic. And then you have to combine like terms to make one quadratic. And then you would have to do the quadratic formula, or you would have to factor it to then get the two solutions. And then there's going to be one that's negative and there's going to be one that's positive, and the negative one can't be a solution in geometry because we just can't have negative lengths. So it would be the positive one. We're not going to do that. Okay. So instead, there's this like cheat way. What we're going to do is we're going to take the small triangle, one of the sides, and we're going to divide by this proportion. And then we're going to take this side and we're going to divide by this proportion. That way we cheat the system and don't have quadratics. Because in geometry, you don't really have quadratics. Could you do that other one? Yes, we're not going to do that though. So let's go back to the side. So we're cheating the system today. You can only do this whenever you have arrows and arrows. You would get the same answers though if you did the quadratic formula versus doing this method. You get the same thing. Let's jump down to number 3. Okay, so what's on my small triangle? X over 36 because they're on the same line. There is a 10 because this is 45. This is whole thing's 55. So this is 10. So 10 over what? 45. So take a second. We're going to cross multiply. We won't have quadratics. It's going to be beautiful to me. Great day because I'm not doing the quadratic formula. So what does X equal for this one? 8. Easy peasy. Lemon squeezy. Let's do number 5. If I pick something on the small, let's say I choose 30, take a second, set up the rest of the proportion. If I choose 30 first, then everybody's proportion should be set up the same. So what should be under my 30? X plus 7. What's my fraction on the other side? 25 over 15. So we're going to cross multiply. This one we will have to distribute because we have X plus 7. So you have to distribute. So we're doing 30 times 15, 450. And then we have to distribute 25 into X plus 7. So don't forget to distribute the 25 to the 7. And then it's a two-step equation. So I'm going to minus 75 or 175 minus 175 and then divide by 25. Whenever I do 450 minus 175, 275. And then what's my answer? X equals 11. How do we feel? Easy peasy? Yeah. That's not bad. Let's go to the next set of questions. So the next set of questions, the directions, if you look, 7, 8, and 9 do not have any X's in them because you're not solving for X. It wants to know, are these two lines actually parallel to each other? So I need to justify that they're parallel. So if they're parallel, their proportions should equal the same decimal. So we're going to pick something on the small. So if I pick 11, 11 divided by 15.4, because they're on the same side, should be congruent or should be equal to 10 over 14. So just like we were doing, I think 2 days yesterday, we're going to divide. If we get the same decimal, we say yes. If we don't, we say no. So all day the same? Heck yes. Try number 8. So when you divide, are they the same? No. So you just say no. Okay, next set is literally the same thing. It just looks crazy. So for the last pictures, this is the same thing. They just cut off the rest of the parallel lines. So this is making triangles, but if this line, because they're parallel lines, if they extended forever, then they would have these like little weird lines that like stick out on each side, right? We just have these like extendo lines. That's what these are. Okay, so it's the same process. Okay, we just don't have a triangle. So for proportional parts of parallel lines, we're going to use the same rule. First thing I'm going to do is I'm going to say, if I know AB, that line, if AB is parallel to CD, because I have these little double arrows, which is also parallel to the third line, EF. Okay, so all these lines are parallel. That's why it looks crazy. We have lots of parallel lines. Then I'm using the same exact proportion. So if I call this W and I call this X and I call this Y and I call this Z, just because like it's easier than writing a bunch of letters like AC and over CE and BD over DF, I can use the same proportion. I'm doing this part, W divided by Y equals X over Z. So same exact thing. Now the thing here is you just need to make sure you're using the same line. All of these are on the same line. All of these are on the same line. Okay. You're not like jumping across. So let's go to number 14. So number 14, we don't have a small triangle anymore. So we're not necessarily looking at a small triangle. Let's pick anything on the picture. So somebody pick something on 14. 24, sure. So 24 is over that same line, the other piece. So we're going to say 24 over 18. Now I'm going to look at the other line that's not parallel to all of these parallel lines, okay? What would have to go up top if I put 24 up top? 3x plus 1. So if this is on top, then that's on top. And then what's my denominator? 12. And then it's the same process. I'm going to cross multiply. So it's the same thing. The picture just looks crazy. So we're doing 12 times 24. And then we're going to do 18 times 3x plus 1. Eighteen times 3x is 54. 18 times 1 is 18. And then it's a two-step problem. So I'm going to subtract 18. And then I'm going to divide. Yeah. 8? Yeah. Like regular tape? Yeah. What's wrong? No, it doesn't. I don't know if tape's going to work for what you're doing. Really? Okay. Yeah. I'll put it in. What's with this? Here you go. Okay. What do we get? Oh. Would you like to do one more? Or are we feeling okay? Or like, it's the same thing on the back. Let's try to set up 15 and then you guys can do 15 and we'll start out. So 15, you're picking anything on your picture. Literally anything. So let's say I choose 21. Take a second and try to write the proportion. What's up? What are you doing?
Nice thinking for the past 10 minutes.
Yeah. Where are you supposed to be going?
It's careful.
Oh.
I'll be working.
Mm-hmm. Mm-hmm. Yep. That's correct. You have one on your knee too. Yeah. Oh, okay. So when you distribute and you solve, what do we end up getting? 13. Okay. Would you like to know which ones are decimals? Okay. So on the front, there are two more decimals. So on the front, number 10 is a decimal. Okay. So if you want to like circle it, so that way you know, just like be aware that's a decimal. 4 is also a decimal. So on the front, 10 and 4 are decimals. So if you want to put a little star or circle it, 10 and 4 are decimals. On the back, the ones that are decimals. Where's my back side answers? Okay. On the back, number 2 is a decimal. And 10 and 11. 2, 10, and 11 on the back are decimals. I'm gonna pass out papers because I have more papers.
Are we